All right, so we started by defining what a vector is, what a scalar is, right? Then you saw how to break vectors into components, right? Then we saw how do we add vectors using components. Awesome. Well, let's just ignore that bit right there. That guy's gone, right? Now what we've got is we have, remember how we added the vectors together and that's how we got R, right? But now all I've really got, I know like the magnitude, I know the length of the drawing and I know the angle, right? But I don't actually know the number, correct? I don't actually know the number. So what I need to do, but I know the components. In this case, essentially we broke it into components, vectors into components. We added them together, and we're left now with the components of the resultant. Does that make sense? So like we're starting here, we broke it down. Now we need to recombine them to get the answer back out. Okay? We've got another right triangle. And if this is R, right, we know that this is R sub x and this is R sub y. Right? Those leftover bits and pieces are the components of our resultant. Right? What happens when we put them all together. Awesome. So now, how do I go, and again, if this is our angle theta, how do I take these two things here and give me this back? What do you think? How do I take these two, how do I take the magnitude of R sub x and the magnitude of R sub y, how do I get the magnitude of R, what the actual like velocity is, or the actual displacement? How do I find that? Pythagorean theorem, right. Pythagorean theorem. So in this case, I know that it's a squared plus b squared equals c squared. Correct? I never write it that way. I always write it as r is equal to the square root of r sub x squared plus r sub y squared. Okay? So if I have components, and remember, this is really, really important again, components are always perpendicular. If I have components, I can add them back up to find the resultant, what the real thing actually is, by using the Pythagorean theorem. But I need the angle as well. I can't just give me the magnitude. I also need the angle. How do I find the angle? How do I find that theta? Ooh, no. Tangent. Right? TOA. Opposite and adjacent, right? There we go. So I know the tangent of theta is equal to the opposite over the adjacent. So in this case then, tangent of theta, the opposite is r sub y over the adjacent is r sub x. But I don't want tangent theta, I need theta. I don't want tangent theta, I need theta. How do I get just theta? Inverse tan. So theta is equal to the inverse tan of r sub y over r sub x. There you go. Okay? So we looked at how do we break vectors into components, and then how do we take those components and combine them back into vectors. Okay? What you also saw, and I failed to make it explicit, was when components or vectors are parallel, they're on the same line, we add them. Right? So these two we subtracted, right? Because one went this way, one went the other way. Because they're on the same line, they're parallel to each other, we just subtracted them. These two we added because they're pointing in the same direction. Okay? It's when we get to the perpendicular ones, we have to do this. So our goal is to make everything parallel and perpendicular. Right? If it's at an angle, if we can make it parallel and perpendicular, our life is super simple. We've got these things and we've got the components as well. Okay? So that's our goal there.